Hey y'all, did you know that the Great Barrier Reef is the world's largest coral reef system with over 2,900 individual reefs and 900 islands stretching over 1,600 miles? The reef is located off the coast of Queensland, Australia. The Great Barrier Reef can be seen from outer space and is the world's biggest single structure made by living organisms. That is crazy. The reef is believed to be over 500,000 years old, but now the reef is in danger. Due to climate change, the Earth is warming. More greenhouse gases are being produced. The ocean absorbs half of this extra carbon dioxide. It reacts with seawater, forming carbonic acid, which causes the acidity to rise. This means that the oceans are 30% more acidic than they were 250 years ago. Bad news for coral and our other sea creature friends. The lower pH makes it more difficult for marine creatures to build their shells, and it causes the coral to dissolve. The lower pH causes the reef to die, and nasty, slimy algae move in. So, what is pH? pH is used to define an acid's strength. The more hydrogen ions present in solution, the greater the acid strength and the lower the pH. Turns out, pH is an abbreviation for the power of hydrogen. So, you've probably seen something like this before. Acidic solutions have a pH of less than 7 and turn litmus paper red. Basic, or alkaline solutions, have a pH that is greater than 7 and turn litmus paper blue. Neutral solutions have a pH of 7. To keep it straight, you only need to remember that bases taste bitter and turn paper blue. Bitter, base, blue. Anyway, you're not in 8th grade anymore. Time for big boy science. You know that ionic compounds break apart into ions in solution. Water dissociates too. Acidic solutions have more hydrogen ions than hydroxide ions. Basic solutions have more hydroxide ions than hydrogen ions, and neutral solutions have equal amounts of ions. The brackets around the ions tell us we are dealing with concentrations or molarity. Thought you could forget about molarity, huh? Molarity is, of course, concentrations in moles per liter. Now back to pH. It is a logarithmic scale that runs from 0 to 14. So, what's a log? And no, I am not talking about the remnants of a fallen tree. No, really, why use a logarithmic scale? The pH scale is often used instead of molarity because solutions can have such a ginormous range of hydrogen ion concentrations. For example, in a typical acid-base titration, H plus may vary from about 0.01 molar to 0.00000000000001 molar. It's easier to write the pH varies from 2 to 13. Check out this crazy chart. A log scale is better because there are just way too many zeros to keep track of. Duh. A solution with a pH of 6 is 10 times more acidic than a solution with a pH of 7. And a solution with a pH of 10 is 1,000 times less acidic. Okay, now time for a little math. Sorry, don't hate me. All right, this formula says the pH is the negative log of the hydrogen ion concentration in a water-based solution. Here's an example you might see. Calculate the pH of a solution with a hydrogen ion concentration of 6.3 times 10 to the negative 4 molar. Here's what you do. Put the molarity number in the formula where the H plus goes, then type it all into your calculator. So we're going to put 6.3 times 10 to the negative 4 where the H plus is. All right, so on your calculator, press the log button. Then enter 6.3 times 10 to the negative 4. Remember, use the second EE button instead of entering times 10. All right, now close your parentheses and press enter. So the log of 6.3 times 10 to the negative 4 is negative 3.2. So if I look back at my formula, I see the pH is the negative log. So what is my pH? Two negatives make a positive, so the pH is positive 3.2. And this makes sense because the pH scale only has positive numbers. All right, one more thing you got to know. The pH balance of water is 7. Since it's a neutral solution, the hydrogen ions and hydroxide ion concentrations must be equal. So keep this in mind. pH plus pOH is equal to 14. So if you know the pH of a solution is, say, 2, the pOH can be found easily, right? You just have to do a little simple elementary math. Let's try it. Here's my formula. Plug the 2 in for the pH. Now use some simple algebra and solve for the pOH. So the pOH of a solution that has a pH of 2 has a pOH of 12. Easy peasy. One more thing. pOH is equal to the negative log of the hydroxide ion concentration. If given the hydroxide ion concentration, the pOH can be found in much the same way as the pH. Then, once you have the pOH, you can solve for the pH. Got it? Here's an example. If the hydroxide ion concentration is 4.82 times 10 to the negative 5 molar, what is the pH? Okay, let's start with our formula. Now let's plug the hydroxide concentration into the formula. Now back to the calculator. Press the log button and enter 4.82 times 10 to the negative 5. Remember, use the second EE button. Close your parentheses and press enter. The log of 4.82 times 10 to the negative 5 is negative 4.32. Okay, so the pOH is what? That's right, positive 4.32. So, are we done? Let's look at our problem. The problem asked us, what was the pH? We have the pOH, so we are not done. So we have to use this formula again. This time, we will plug 4.32 in for the pOH. Use some simple algebra and solve. So the pH would be 9.68. After enough practice, you'll see it's not too hard. But what about the coral reefs? What's going to happen to them? Well, the reefs are crumbling and habitats are being destroyed. What has taken hundreds of thousands of years to build may never be the same. So how can you help? Well, look into ways that you can reduce your carbon footprint. Until next time, it's Lisa D. See you later, y'all.